Okay, so good morning, students.
Good morning, sir.
Good morning.
Sir.
My name is Professor Tanmay Das, and I will be taking your subject of electromagnetic field theory. Okay, so since this is the first class of you all as a lateral student in the at the college in the department, so I welcome you from the Department of Electrical Engineering. So basically, today is an introductory class. Okay, so I will just give an idea because the regular students who have been studying in the second year, okay, have already completed the syllabus, most of it, okay, and their exams are going on. But since the JUT has started the semester for you lateral at later, so your exam will be conducted after a few months, okay. Uh, that date will be declared to you. So basically, to your first class, so I would be just giving an introduction. So you have few subjects. If you have the syllabus with you, that is good. Okay. Otherwise, you can ask. You can also download from the college website also. Okay, college website as well as the JUT website. That is the Jharkhand University of Technology website. You can download it from there. So there are few subjects such as the electric circuit theory, okay, and circuit and network theory, which is already most of it is known to you because you since you have studied diploma. So you have some basic idea about electrical machines because machine subject is also there. Okay. And one second. Yeah, so electrical machine is also there. And the subject which I will be teaching you is actually electromagnetic field theory. Okay. So I will not I will not waste too much time because I would rather suggest that since you have joined, so it is now high time. So you must start your preparation from now on. Okay. So you must start your studies for the this semester from now on. So electromagnetic field theory. So electromagnetic field theory, this subject. Okay. Let me share the syllabus with you first. That will be better for you. Okay, since you are new, so those who don't have the syllabus, they can look at the syllabus. Let me share the screen. Please wait for a minute. Okay, so is my screen visible?
Yes, sir.
Okay, so you can see this is the, oh sorry, this is the, wait, communication. Yes, this is the syllabus for the electrical engineering third sem. Okay, so first of all, you will be having electrical machine, then network theory, then electromagnetic field theory, basic electronics, mathematics 3, environmental science. And corresponding, you will be having your laboratories. Okay. Now, the subject which I will be teaching you is electromagnetic field theory. So, this subject do not have any lab. Okay, so only 4 classes a week. Okay, theory. One second. Let me go to the detailed syllabus. Yes. So, this is the detailed syllabus. Okay. So, there are few modules. Okay, 5 modules rather. So this is basically related to the some few portions are also in mathematics also. Okay, divergence, curl, all these things, and basic knowledge you have to know, that is the vector knowledge. Okay, and the coordinate systems also. So first module that I will be teaching you is the coordinate system and the transformation. Okay, So let us start with the first lecture. Okay, just introductory part. So lecture number 1, which is the module of the coordinate systems and transformations. So starting with it, first of all, the basic vectors. All of you know what are vectors? Anyone?
Yes, sir.
Please, what is a vector?
Sir, a quantity that has both magnitude and direction.
Yes, a quantity that has both magnitude and direction. Okay. Okay, so magnitude and direction both possesses by that quantity. So give an example of a vector. Uh, an example of a vector.
Displacements.
Displacement. Yes, displacement, force, okay, velocity. These are all vectors. And an example of a scalar.
Sir, distance, speed, potential.
Potential, speed. So basically, that is the general meaning, because speed is the magnitude of velocity. Okay, because of vector has magnitude and the direction. So if you find the mod value, that is the speed. Okay, and displacement, the magnitude of displacement is distance. Now there are few other parameters which are totally scalar quantities, such as mass, okay, volume, okay, these are all scalar quantities. Now in this electromagnetic field theory, the subject name is electromagnetic field theory because it contains the concept of electric field and magnetic field. So we will be studying the different laws of electric field, including vector, okay, as well as the magnetic field including vector, and the combination of the two, that is the relationship of these two. Because whatever communication signals we see, okay, that means the radio signals, okay, and in fact in transmission line also, when the power is transmitted, okay, that is the current is having sinusoidal nature, the alternating voltage is also having sinusoidal nature. So they also possess some electromagnetic wave in the form of, they travel in the form of electromagnetic wave. So in transmission line also electromagnetic wave study is done. That is why the electromagnetic field theory is very important for an electrical engineer. Okay. So basic vectors all of you know, so I am not going into details. So I will be sharing these notes with you. Okay, so I have already created a Google Classroom for the normal regular students of second year, third semester. So I will share you the same class code. Okay, over there you can get these notes. So these are the just the basic, you can say, definition of vector. That is force is a vector quantity. Okay, so these are the some scalar and vector quantities. Okay, that is distance, mass, temperature, pressure, work, energy. These are all scalar. And displacement, force, velocity, acceleration, these are all vectors. Okay. Now addition of vectors, all of you know, you have to use this triangle law. Okay. All of you know, or shall I repeat? I think all of you know this. How to add two vectors. Okay, I hope all of you know this. So I am not going to this. So subtraction of vectors, multiplication of vectors. Multiplication of vector means you can multiply a scalar quantity with a vector. That means suppose A is a vector and you want to increase the magnitude of that vector. That means direction you cannot change, but you have to increase the magnitude. You will just multiply a scalar multiplier with it and its magnitude increases. Also, if you want to change the direction, yes, direction you can change, but you cannot deviate. You can just make sure that if the direction is in this point, it is directed towards this way, then you can change the direction the opposite way. That means you can multiply with -1 or minus a. So that means the direction is reversed. You can only reverse the direction. Okay, then we have the unit vectors. Okay, unit vectors means any particular vector, if you divide by the magnitude with a vector, you get the direction. So direction itself is a unit vector, or magnitude 1 and direction. Now introduction to the coordinate systems. Now this is the main part which you have to study. Okay. So coordinate systems. So coordinate systems means that our universe, okay, everything we see through our naked eye, we see in 3 dimension, 3D. Okay. So now the basic way to define a 3-dimensional coordinate is by using the rectangular coordinate system, which is also called the Cartesian coordinate system, that is x, y and z plane. Okay, that means any coordinate system, any particular object, a location of an object can be detected, can be located by using this coordinate system. Suppose x, y and z axis. This is suppose x axis, this is y axis, this is z axis. Okay, from now on you have to keep in mind that you have to follow this particular orientation, that is the x axis will be along this line, y axis will be along this line and z axis will be along this line, and all are 90 degree to each other, perpendicular to each other. Okay, now since these are called the axis, x axis, y axis, z axis. Now these axes are all perpendicular to each other, that is why the coordinate system is called orthogonal. Orthogonal coordinate system means the axes which are there, the different axes, the plural of axis is axes, A-X-E-S. The axes which are there or are perpendicular to each other, that is why it is called an orthogonal coordinate system. The coordinate system in a way uniquely satisfying the location of any position in a space with respect to a reference origin. That means location of a point. Suppose this is called the origin, this is 0, and if you have a point over here somewhere in 3 dimension, okay, somewhere over here, so point P, so how to locate it? We just draw a line like this, perpendicular line on this xyz plane, 2-dimension plane. Then you will measure that what is, you will extend up to here, you will see what is the distance. If the distance is suppose 3 unit, and you will extend up to here, perpendicular line, cut it over here, this is 4 unit, and you will join it over here, suppose this is 5 unit. So this point is having 3, 4, 5 x, y, z coordinates. Okay, 3, 4, 5. That means this is the way to locate a particular point in a Cartesian coordinate system. Okay, this is the way. Okay. Now in Cartesian coordinate system, you can also locate a vector also. Okay, that we will come later on. So as I've told you, the coordinate system may be orthogonal or non-orthogonal. The coordinate system can also be right-handed or left-handed. So we discuss only right-handed orthogonal coordinate systems, this one, okay, which are mutually perpendicular to each other. So I've already told these things which have been written over here, so I'm not repeating. Now the last point you can see, last point tells you that what are the different coordinate systems that we will be studying, that is there in the syllabus. XYZ plane, which I have just now discussed, comes under the rectangular coordinate system, which is also called the Cartesian coordinate system. Then we have the cylindrical coordinate system. This is another type of coordinate system, same 3-dimensional. And this is the another one is the spherical coordinate system, which is the third one. Okay. So three coordinate systems are there. All the three are actually for 3 dimension, but they are actually of different, as per requirement. Okay, because Cartesian coordinate system is the most common one, but cylindrical as well as this is called the circular coordinate system, which is also having the name of cylindrical. Okay, circular cylindrical means you can also write cylindrical coordinate system. So cylindrical coordinate system is also another type of coordinate system. Okay, and third one is the spherical. Now why the names are like this: rectangular, cylindrical, spherical? Just a brief idea I am giving you, because when you will study into details for the each coordinate system, then you will have the clear idea. So the basic reason is that rectangular coordinate system, which is the Cartesian coordinate system also called,
here we consider that the whole universe is like a rectangle. Okay, like a rectangle means our, as if the, if I draw this xyz plane, okay, if you see, then it will be easier for you to understand. Next slide. Okay, this one, this is as if the entire thing as a rectangle. Okay, but if you are unable to understand, then I will go to the previous one over here. Okay, suppose we have the rectangle like this. We draw a rectangle or a cube. Okay, three-dimensional rectangle is called a cuboid. Okay, we draw like this. If you consider this particular junction, okay, this particular junction, you can see it is like the corner of a room. Okay, suppose this is your z axis, this is your y axis, this is your x axis, or minus y, plus y is over here. That means every point you will see it is kind of a xyz plane. Okay, you can relate it. That means the coordinates are the axes are perpendicular to each other, but they are also in the shape of a rectangle. That means any point anywhere, as if you can draw a small rectangle everywhere. Okay, you can draw a small rectangle, you can draw a bigger rectangle or bigger cube. Okay, that means the whole universe where you are standing is actually a cube. Okay, is like a cube. Okay, like this. Cylindrical coordinate system is like that. The whole universe is like a cylinder, in the shape of a cylinder, which is having some height, a base. Okay, and it can be a narrow one, it can be a broad one, any shape we can get. Okay, that is a cylindrical coordinate system. It can be a longer one, any shape. And spherical means the whole universe is shape of a sphere. Sphere means like a ball. So wherever you go, it is like a sphere. It is not like a rectangle, it is like a sphere. So these are the assumptions as per the calculations that different scientists have made. Okay, assumptions are made. Different coordinate systems have been developed. Okay, there are more, but these three are the major ones, basic ones, so that you have to study. So I will just show you this particular picture which I have just shown you before. This is showing that, first of all, concentrate on the axis. Okay, x, y, z axis. This is the x axis, this is the y axis, and this is the z axis. Now these are three-dimensional, but you can also make them two-dimensional. How? You just draw a line like this. What you get, this you call it a plane. That means a two-dimensional plane, which is nothing but the xy plane. Okay, so any point which is on this plane, we call it, that point is located on the xy plane. So you will have some x coordinate, y coordinate, but z coordinate will be 0. Why 0? Because xy plane is actually placed where z is 0. Okay, at the origin. Similarly, you can also draw this line, okay, from z and from x also. So you get another plane, two-dimensional plane. This is called the xz plane. Here, if you have any point, that point will not have any y coordinate. Okay. Similarly, if you join this z and y, you get another plane which is called the yz plane. Here you don't have any x coordinate. Okay. All right. Now, if you want to lift this x y coordinate upwards, if you want to lift it upwards, as if you are lifting this one is going upwards. Okay, if you are lifting upwards, then what will happen? Slowly your z will increase. Okay, that means what is being said over here, that the whole coordinate system is like a rectangle, like a cube, but it is called a rectangle. Okay, now just I have shown you previously in the previous slide that the dimension cannot be restricted. That means it can be a small cube, okay, it can be a bigger cube, okay, but there will be parallel, all the cubes will be parallel to each other. Okay, all the cubes will be parallel to each other, so there is no limitation. So how much the size the cube will be having, okay, there is no limitation. So that means everywhere if you want to expand it, you can either, you have to expand the planes individually, एक एक करके plane को increase करना है, expand करना है. The top one is actually the xy plane, this top one is xy plane. If you want to expand it, if you want to increase the size or if you increase the height, then you have to expand it upwards. If you want to expand the xz plane, then you have to expand the sideways. Okay, this one, either you have to go left or right. And if you want to expand the y is xy plane, then you have to expand the front one, that means this one. Okay, that means this is actually increasing. So the actual size is not known. Okay, we don't know. Whole the universe is suppose in the rectangular coordinate system or Cartesian coordinate system. So we can draw small boxes like this to locate a point, okay, as per the requirement. Okay, so you can consider that point anywhere, okay, or in any plane, or if it is not in a plane, then you have to consider it in the having the 3 coordinates. Okay, just the conceptual, it is the conceptual part. Now this is the way of locating a particular point on the Cartesian coordinate system. I am just giving you a brief idea before. So this is this particular diagram shows, figure number 8 shows that the axis which I was talking about, okay, x-axis, y-axis, z-axis, all have positive direction as well as negative direction also. That means x-axis we all know that it is towards you, y-axis is towards the right hand side, and z-axis is upwards. That doesn't mean that if you extend this is the origin, if you extend it backwards, then you will have the minus x-axis. Okay, because this is x, this is y, this is z, and if you extend them backwards, I'm using another color. If you extend them backwards, then you will have minus x. If you extend it on this left hand side, you will have minus y, and if you extend it downwards, then you will have minus z. Okay, so that means in every direction you can plot. Okay, so suppose this point is over here at this particular place. So it is observed that it is having some, means this is the z axis, so it is behind the z axis, so it is not in the yz plane. Okay, it is not in the yz plane, so it is behind that. So that means it is on the minus x axis, and it is observed that it is having a point minus 2. So we will write up minus 2. Then the y axis will be, the y axis, it is having a point of 2 plus 2. Okay, so it is over here. If it is on this left hand side, it will be having minus 2, but it is on the right hand side, it is having plus 2, and height is 3, suppose. So this point will be written like this: minus 2, 2, 3. Suppose this point, okay, which is floating somewhere in the air. Okay, so it is having 3 x-axis, and it is left hand side of the origin, so it will having minus y. So minus y is 2, and height is 2. So 3 minus 2, 2. If you are having any point over here, suppose over here, okay, then you will have positive x, positive y, but negative z. Suppose you will have 6, 7 and -4. You can have a point like this. And if you have a point over here behind, so behind this, okay, somewhere, it is not possible to represent 3 dimension in a computer screen, because computer screen is 2 dimension. Okay, so just, and for that is why we use this location points, okay, to actually understand the location of the everything. Because if you see, when the 3D graphics is done in a computer, visual graphics, okay, and the VFX, whatever is done in the movies and everywhere, all use 3D technology, but they do all these things on a computer. So computer screen is 2D. We don't have a 3D computer screen, okay, we have a 2D computer screen. So how to replicate it? That is why these coordinate systems are used. Okay, to design a 3D model inside a 2D screen by seeing at a 2D monitor, it is not possible until and unless we have these coordinate systems. That is why the coordinate system study is done. Okay. So suppose this point is over here, so we will have, suppose, -3, -4, -5. Okay. So we can look at like this. Understood? Any questions from your side that you can ask? Any questions, students?
Sir,
Yes.
sir, according to the question, we can adjust the axes, or according
No,
to
no,
the
no, no.
axis.
No. You cannot adjust the axis. Always remember, in Cartesian coordinate system, you will have first 3 axes which are perpendicular to each other. You have to name this x. You cannot change it. You cannot give it y. No. This is x, this is y, this is z. This is the convention. Okay. This is the convention which is used everywhere. If you write it x, then you will not be able to solve the problem, because whenever the question is given to you in the exam or anywhere, in any field or any wherever you are working, everywhere you will see that x is represented on this direction, y in this direction, z at this direction. Okay, this is a convention, you can say. Okay, you cannot change it. If you change, then you will not be able to work. And whatever you have on the other axis or other way, because this is origin, so on the other it will be -x, here it will be -y, and here it will be -z. Got it?
Yes, sir.
Okay. So now that means from here you can locate the different points, and as well as okay, all these things. Okay, the same thing has been actually drawn over here, so I missed out. Wait. Okay. Now one more thing is that I will not discuss. Okay, so I will rather discuss in the next class. Okay, because there are vector part, because this figure number 9 is showing the vector part. Okay, because Cartesian coordinate system, these coordinate systems are not only used for locating points, because points are scalar, this is scalar, but it is also used for locating vectors also. So vector part we will come later on in the next class. Okay, because that will be better. So now limits, before going to the vector, I am just showing you the limits, because in every coordinate system you will come across this particular limits of each coordinates, because x is one coordinate, y is one coordinate, and z is another coordinate. So 3 coordinates you can see, they don't have a limit. They can extend from -infinity to +infinity. Why it is given? Because in spherical coordinate system you will see that one axis is not represented by values or magnitude, it is represented by angle. And in spherical coordinate system 2 coordinates are there which are represented by angle. Okay, so that is why infinity will not come in that case. But in Cartesian coordinate system we don't have any angle, we just have measurements, distance. So all the coordinates are having infinity range, -infinity to +infinity. So vector part we will discuss in the next class. Okay, so any more questions from your side?
Sir, the range
Yes.
from the range of x-axis, y-axis, and z-axis, we include -infinity and infinity.
Yes, minus infinity and plus infinity. Because as I've told you that this particular, you can see this is x-axis and behind we have minus x-axis. So any point can be there. It can be 1000, 1 lakh, 10 lakh, 1 crore. In back also there can be minus 1 crore. Okay, so there is no limit because we don't have a limit of the universe. Universe का limit पता है किसी को? नहीं पता है ना. तो हम लोग infinity समझते हैं क्योंकि तारे जो स्टार है, स्टार का डिस्टेंस हम लोग मापते हैं लाइट ईयर्स में. ठीक है, तो उसके पीछे भी मिल्की वे गैलेक्सी के अंदर जितना भी स्टार है वो भी लाइट ईयर्स में है. तो उसके बाहर भी तो गैलेक्सी है, तो कोई लिमिट नहीं है यूनिवर्स का. इसलिए एक्स वाई जेड का भी कोई लिमिट नहीं है. तो माइनस जो जहां से तुम ओरिजिन पकड़ते हो, अगर सामने देखोगे तो प्लस इन्फिनिटी, पीछे देखोगे तो माइनस इन्फिनिटी. दाएं देखोगे तो प्लस इन्फिनिटी वाई एक्सिस, बाएं माइनस इन्फिनिटी. ऊपर देखोगे तो प्लस जेड जेड एक्सिस इन्फिनिटी, नीचे देखोगे तो minus z axis up to minus infinity. So there is no limit. Anywhere you can place a point.
Sir, but in the two-dimensional we exclude minus infinity and plus infinity.
No.
Within,
No, yes,
within it.
obviously, because in no, this is the practical case. Because in calculation we don't generally use infinity. This is just a representation that what is the range. That is infinity. ऐसा नहीं है कि 100 तक ही जा सकते हैं. It is not like that. Just for your understanding that it can be anything, so it is infinity, the actual range. Okay, but yes, obviously when you are calculating and all these things, you will not have you come across infinity before. Whenever you see, everything is having some limited value. We write infinity because we don't know the limitation. जिस दिन यूनिवर्स
Yes,
का
sir.
जिस दिन यूनिवर्स
Sir,
का हमको लिमिट पता चल जाएगा, उस दिन इन्फिनिटी लिखना बंद कर देंगे हम लोग.
the limits for the
हाँ
coordinates are here. It is written.
हाँ
Then
हाँ.
it is equal to and greater than sign. Sir, equal to sign is right or right here.
Equal to sign is right here. No, because see, it is written here equal to and greater than. Equal to and greater than मतलब क्या है? What does it mean? Equal to and greater than means that see, minus 5 and minus 4, which is greater?
-4, sir.
Minus 4 is greater. That means if you have minus infinity, so any value, suppose minus infinity minus 1, so that value will be greater. And minus infinity
Yes, sir.
minus 2, that value is greater. So that means if you are going towards the origin, so that means it is told that whatever you have, x-axis will be either equals to minus infinity or greater than that. Okay, and
Yes, sir.
and if x value is 100, then 101 will be greater, 102 will be greater, so infinity will be greater. That is why it is written like this. Infinity is equals to, because otherwise x can be infinity. Suppose x is infinity. Okay, because we don't have the limit. That is why it is given like this, x equals to infinity. This is theoretical. Practically it is not possible. Practically there is no resemblance of infinity. There is nothing called infinity in practical. Okay,
Yes, sir.
whatever we have explored in our mankind, once we explore, because before we explore the distance of sun, we used to say, oh, sun is huge, distance we cannot measure. Now we know the measurement of sun. Okay, now we know the measurement of speed of light, speed of sound. So slowly we are exploring. Once we explore the limit of the universe, then we will not use infinity sign. But still now we don't know the limit of the universe. That is why we say that yes, equals to infinity, it can be equals to infinity or less than infinity. Okay, this is the way of representing. This is the mathematically, it is always written like this: equals to and equals to greater, equals to less than, always. So plus
Yes,
infinity
sir.
is
Yes.
always less than equals to, and minus infinity is always greater than equals to. Okay. Okay, so good. So any further questions? So good. So I am happy that you are interacting. So it is very good that you must interact like this in the class. Okay. Okay. So I think for the first class it is enough. So as per the routine, so we will continue. So in the next class I will be discussing about the vectors. So how to represent vector in the Cartesian and how to do the calculations and what are the numericals associated with this particular topic, that we will discuss in the next class.
Okay, sir.
Okay, okay, students. So then thank you. then we can end this lecture.
Sir, the code Google Classroom.
Google Classroom I will share. I will share very soon. Okay. Okay.
Okay, sir.
Okay. Okay. Thank you.
Okay, thank you, sir.
Thank you.
Thank you, sir.